All right, so here we have salt leakage. A container of salt sitting on a shelf in a kitchen cupboard. As salt leaks out of a hole in the side of the container, it forms a conical pile on the counter below. As the salt falls onto the pile, it slides down the sides of the pile, so the pile's radius is always equal to the height. All right, so what we have is we have some jar and it's leaking salt, and basically it's making some kind of a pile, and we know that radius is equal to height, so we can interchange those equally, it looks like. Now the height of the pile is increasing at a rate of 0.2 inches per day, so the radius is increasing or the height is increasing 0.2 inches per day. And how quickly is the salt leaking out of the container when the pile is 2 inches tall, and how much salt has leaked out of the container by this time? All right, well, let's go through these step by step. And so we have our dependent and we have our independent. Dependent, well, we have volume is going to be one thing because we want to know how much the volume is. So the volume will be a dependent. And it's in inches, so the volume is going to be in inches cubed. And then the radius is equal to the height as equal to inches, okay, because we know radius and height. And so independent is going to be time, and that's going to be in days, it looks like. So we have our days, okay? So those are all our variables, I think. Now, what is step two? Well, step two says write an equation. So now what we need to do is we need to know a volume of a conical pile. Now, if you don't know what that is, we just have to go and look it up on Google or look it up in some other math book. And if we do that, we find that volume is equal to 1/3 pi r, oops, I'm writing too many letters here, pi r squared h, okay? Now, anything here that we know, well, remember, we know r is equal to h. So what we could do is we could say, well, this is equal to 1/3, where'd my pi go? Pi r squared h. So that's equal to 1/3 pi r cubed, or 1/3 pi h cubed, because we know r and h are the same, so we could take that h and make it an r and make it r cubed, or we can take those r squareds and make them h's and make it h cubed. So we can go kind of both ways here depending on what we think is what we need to do. Well, it tells us, the pile is increasing at the height as by zero point 0.2 inches per day. So if we use the second one, then we would have it as the height, and that's one way to do it. But we always know that r is equal to h, and so we could have it as its radius is increasing by 0.2 inches per day as well. So one of those problems where everything works out no matter which way we go. It just depends on which variable we use. All right, so that means step 3 is next, and that means we're taking the derivative. So we're going to use that as our left side. So d dt of v is equal to d dt of, now let's go ahead and use that one just because, 1/3 pi h cubed. Well, that gives us dv dt equals, now we're going to have to take it with respect to that, so we'll bring down a 3, so we'll have 1/3 pi times 3h, now it's squared, and that's dh dt. Now again, our 3's are going to cancel, and so dv dt is equal to, now we have pi h squared times dh dt. All right, so what do we know? All right, so when the pile is 2 inches high, so we know h is equal to 2 inches, and dh dt is equal to 0.2 inches per day. So step 4, we're going to use those two pieces and we're going to solve for dv dt. So that's going to be pi times h, which is 2 squared, times 0.2. And that gives us, well, we'll just take pi times 2 squared, which is 4, times 0.2, and we get 2.513. 2.513 doesn't round up, and that's going to be inches cubed per day. So that is how big the volume is increasing as it keeps pouring out of here. Okay. Now, how much salt has leaked out of the container by this time? Okay, well, at this time, we know that's 2 inches, and we can say, okay, well, how much salt we are just going to find how much volume is basically leaked out. And so our volume, where's my pen here? Volume at 2 inches is going to be, now we just plug everything in. We know, well, it's 1/3. Then we have pi times h, which is 2 cubed. So we take 1 divided by 3 times pi times 2 to the third, and we get 8.3775. So let's do 378, and that's going to be inches cubed. So that's how many cubic inches have come out of our container up here. Okay, so we don't know as anything beyond cubic inches. We can't do anything else besides that kind of unit, and so that's how much has come out. That many cubic inches have come out of our container once the height is 2 inches tall. So that height there is 2 inches tall. That means we've had 8.378 cubic inches come out of our container. Okay. All right, so that's all I have. So hopefully that'll help you get started.